Today I'm going to be talking to you guys about parallel circuits. So if you have a Christmas tree and you string that Christmas tree with Christmas lights, and if one Christmas light burns out, do all the rest burn out too? Let's see how you can use parallel circuits to prevent this from happening. In a series circuit, as you learned about earlier, all those lights will be attached like this in one big circuit. And if one light burned out, that would cut the circuit and all of the other lights would have to burn out too. But if it were a parallel circuit, it would work out differently. When the light bulbs are attached in parallel, each one has its own loop. Current is flowing through each one of these loops. And if one light bulb burns out, that only affects a small portion of the circuit. So current can still flow through all of the other loops. So when that one Christmas light burns out, all the others can still work. All of those lights have a certain resistance for the current passing through the circuit. To calculate the total resistance of that entire circuit, all you have to do is add up the sum of the resistors. In a parallel circuit, it works out differently. So let's try out a parallel circuit with 5 resistors, R1, R2, R3, R4, and R5. How would you find the equivalent or total resistance? Would it be the same thing as an in-series circuit, R1 plus R2 plus R3 plus R4 plus R5? That also turns out to be incorrect. You actually find the equivalent resistance of a parallel circuit by doing 1 over equivalent resistance equals 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4 plus 1 over R5, and so on until you get the total number of resistors. So let's add values to all of these resistors to try to solve for the total resistance. For the sake of being simple, I'm going to call them all 2 ohms. So R1, R2, R3, R4, and R5 are all 2 ohm resistors. So if we solve this, it's going to be 1 over equivalent resistance equals 1 over 2 ohms plus 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 1 over 2 ohms. That's going to turn out to be 1 over equivalent resistance equals 2.5 ohms. Equivalent resistance, if you solve, is going to be 0.4 ohms. That's pretty small. Even though you keep adding resistors of 2 ohms, it keeps lowering and gets to 0.4 ohms. So adding resistors in parallel actually decreases the total resistance of the circuit. Now let's draw out another parallel circuit. This one has 3 resistors. One is 2 ohms, one is 1 ohm, and one is 4 ohms. This time you guys pause the video and try to find the equivalent resistance on your own. And when you hit play, I'll explain the answer. To find the equivalent resistance, you have to remember our equation. 1 over total equivalent resistance equals 1 over R1 plus 1 over R2 plus 1 over R3. So 1 over equivalent resistance is going to be 1 over 2 ohms plus 1 over 1 ohm plus 1 over 4 ohms, which will turn out to be 1.75 ohms. So that's 1 over equivalent resistance. So that makes equivalent resistance 0.57 ohms. Now let's talk about voltage across a parallel circuit. If there are 20 volts going through this whole circuit, then what is the voltage drop across the 2 ohm resistor? What about the 4 ohm resistor? It actually turns out that the voltage drop across each loop is the exact same as the voltage drop across the entire circuit. So in this case, they're all going to be 20 volts. But what about the current? Is that constant as well through each loop? Well, we can use our simple equation V equals IR, or I equals V over R. We can tell that because the voltage is constant, but the resistance changes, the current also has to change in each loop depending on the resistance. To summarize, in a parallel circuit, you can find the total resistance by doing 1 over total resistance equals 1 over R1 plus 1 over R2, and so on. Voltage remains constant through different loops. However, current changes depending on the resistors in the loops. If you want to learn more about parallel circuits, go to the URL shown on the screen, or search parallel circuits into the search bar at ck12.org.